Hello everyone. In this video, let's go over how to find limits graphically. So we'll still rely on the same definition of limits involving the left and right limit, and the fact that uh, in order for the limit to exist, the left and right limits must both exist and be equal to each other. This time we're just getting the limits graphically. So here we have this graph. It's a piecewise graph, piecewise function, and we have to focus on the limits as x approaches 1 and as x approaches 4. So this is x, here is x equals 1. So let's start with the first one. It's asking for the limit of f of x as x approaches 1 from the left. So let's say we start here. So the goal is the same as we take a look at the graph and locate increasingly closer values to the value of interest 1 on the x-axis. So if we start here, finding the corresponding f of x, we go vertically until we hit the graph, and f of x is there somewhere around 1, slightly above 1. Then we step one step closer. Probably need to enlarge this. So we step one step closer. Let's say here, find the f of x. We read the f of x vertically, we write here. So we just went up, the output went slightly up. We step one step closer, find the f of x. There's clearly an increase as the x values step closer and closer, growing towards the value x equals 1. The corresponding behavior on your graph is that the outputs are increasing towards the value 9. So there's a clear increase on your outputs, the corresponding outputs, towards the output 9. So what that tells us is that the left limit is equal to 9. So that's first limit. We were as 4. So limit of f of x as x approaches 1 from the left is equal to 9. Now the right limit as x approaches 1. So let's say we start here. F of x is right here. Step one step closer, find the f of x. It's right here, and so forth and so on. So as x is decreasing towards the value 1, so starting above 1 and approaching 1 from above, decreasing towards 1, the corresponding behavior is on the outputs is the outputs seem to be growing towards the outputs, the value 7. So that tells us the right limit is 7, is equal to 7. And because the left and right limits are different, that means the limit itself does not exist. So again, it's because the left limit as x approaches 1 and the right limit as x approaches 1 are different from each other. And therefore, the limit of f of x as x approaches 1 does not exist. Moving on to x equals x approaching 4. So this time, let me zoom in. From the left, let's start here, find the f of x somewhere there. We step one step closer, corresponding f of x slightly lower. As we step closer from the left, there's clearly a descending trend towards the value y equals 3. It doesn't matter that, by the way, it doesn't matter that f of 4 does not exist. So whether or not f of 4 exists does not impact or influence at all the existence of the limit as x approaches 4. We are approaching 4 without being concerned about what happens at 4. So the left limit here will be equal to 3. So we can update our work here. The left limit is equal to 3. And as x approaches 4 from above or the right, start here, get f of x, step one step closer, get the f of x, one step closer, get the f of x. There's clear descending trends towards y equals 3. Therefore, the right limit of f of x as x approaches 4 is equal to 3, or the limit of f of x as x approaches 4 from above or from the right is equal to 3. So here, because the left and right limits as x approaches 4 are they both exist and they equal to the same unique number 3, that means the limit of f of x as x approaches 3 exists and is equal to the same 3. Thank you.